Natural numbers and whole numbers. Natural numbers start from 1 and they go on till infinity. Whole numbers include natural numbers and also include 0. So it's 0, 1, 2, 3, 4 till infinity. Half, 3/4, fractions are not natural numbers. Decimals are not natural numbers. 0 is not a natural number. Negative numbers are not natural numbers. If n is a natural number, 2n is always an even number. 2n minus 1 is always an odd number. Let's take an example. Let's say n is 3. 2 into 3 is 6. That's an even number. 2 into 3 is 6 minus 1 is always an odd number. That's 5. Properties of whole numbers for addition. Closure. Whole numbers are closed because on adding two whole numbers, you only get a whole number. Example, 5 plus 7 will only give you a 12. Cumulative property. Sum of two whole numbers remains the same even if the order of addition is reversed. So, 4 plus 3 is the same as 3 plus 4, which is 7. That is called the cumulative property. Associative property. For any three whole numbers, if the sum of any two whole numbers is added to the third number, then whatever be their order, the sum will be the same. For example, 2 plus 6 plus 1 is the same as 2 plus 1 plus 6, which is 9. The identity. How do you get the same identity of the number? By adding 0. So the sum of any whole number and 0 is the number itself. These properties do not exist for subtraction of whole numbers. Properties of whole numbers for multiplication. Closure property. Whole numbers are closed because on multiplication of two whole numbers, you only get a whole number. For example, 3 into 5 will give you 15. The cumulative property. The product of two whole numbers remains the same even if the order of multiplication is reversed. So 3 into 5 is also the same as 5 into 3, which is 15. The associative property. Consider the numbers 5, 3 and 4. 5 into 3 into 4 is the same as 3 into 5 into 4, which is 60. The distributive property. Consider the numbers 5, 3 and 4. 5 into 3 plus 4 is equal to 5 into 7, which is 35. Also, 5 into 3 plus 5 into 4 is equal to 15 plus 20, which is 35. You can distribute it and it will be the same. Identity. How does a number maintain its identity by multiplication? If you multiply it by 1. The identity element for multiplication is 1. These properties do not exist for division of whole numbers. Now consider patterns. See these patterns. 1 plus 3 is 4. You can also put it as 2 square. A number square is a number multiplied by the same number. 1 plus 3 plus 5 is equal to 9, which is 3 square. 1 plus 3 plus 5 plus 7 is 16, which is 4 square. Therefore, the sum of the first n odd numbers is the same as n square. Magic squares. The sum of all numbers in each row, each column, and each diagonal is equal. So consider the top row. 2 plus 9 plus 4 gives you how much? 15. Consider the vertical first row. 7 plus 2, which is 9. 9 plus 6 is 15. You go diagonally. 2 plus 5, 7. 7 plus 8, 15. Now, because of this magic square, you can calculate what the blanks are. How do we do it? Okay, one diagonal is given to us at 6 plus 5 plus 4. So 6 plus 5 plus 4 is 11 plus 4, which is 15. So how do we fill it? 6 plus 7 plus 2, that's 13 plus 2 will give you 15, 1 plus 5 plus 9, then 8 plus 3 plus 4. Matchstick patterns. You can make squares out of matchsticks. Consider one square with 4 matchsticks, 2 squares will be with 7 matchsticks, 3 squares will be with 10 matchsticks, 4 squares will be with 13 matchsticks. Now if you see this pattern, m, or the number of matchsticks, is always 1 more than 3 times n. So if you have to make a formula for it, you can say m is equal to 3n plus 1. Now consider these shapes. If you have to make a triangle with matchsticks, you get one, not square, but a triangle. One triangle with 3 matchsticks, 2 triangles with 5 matchsticks, 3 triangles with 7 matchsticks, 4 with 9 matchsticks. So m is always 1 more than 2 times n. So m is equal to 2n plus 1. Let's find m in terms of n. Now this is the pattern and this is what we find from it. For 2 squares, we use 7 matchsticks. For 3 squares, we use 10 matchsticks. For 4 squares, we use 13 matchsticks. So find m in terms of n. M is equal to 3 times n plus 1. That is, 3 into 2 is 6, plus 1 will give you 7. 3 into 3 is 9, plus 1 will give you 10. 3 into 4 is 12, plus 1 will give you 13.